BBC2. Now counting and remembering, all part of microelectronics in action.
This is Loftus Road, home of Queen's Park Rangers Football Club. On match day, it doesn't stay quiet for long. About 1 hour before kick-off, thousands of fans arrive at the ground. These days, crowd control at football matches is very important. A few years ago, counting the crowd was difficult because the turnstiles were fitted with unreliable mechanical counters. But in this ground, every turnstile is fitted with a microelectronic sensor. Every turn of the turnstile produces an impulse, a count of 1. The impulses from each turnstile are sent to the central computer. This adds up all the impulses and displays the results on a VDU screen in the club secretary's office. The accurate count is updated second by second. Football grounds are divided up into different sections. Each section is fed by its own turnstiles, so the computer can produce a separate count for each section. The microelectronic counting system allows the club to react quickly as the ground fills up.
Chief Steward, over. Tony, paddock, turnstiles 42 to 44 are approaching capacity now. I'll be ready for closure in 5 minutes' time. Over.
And the count is important in other ways.
Inspector Howe from Control, receiving. Can you send 1 and 10 up into the seating area near F block? There is a problem going on there and they need some more PCs up there, please. Over.
In order to arrange their officers as efficiently as possible, the police controllers need to know how many spectators there are in each section of the ground. As the ground fills up, the counting system is used to make sure there's no overcrowding and that there are enough police in each section. With the crowd safely and evenly distributed, the match can go ahead. Microelectronic devices do seem to turn up in some unusual places, doing some unusual jobs. And that isn't the end of the story. Behind the scenes, the work continues. Each turnstile operator brings the takings and tickets to the cash office. Here, the bags are carefully checked in and recorded. Since the count for each turnstile is recorded separately, this should tie up with the tickets and the cash handed in. The club can be sure of keeping the books straight if they have an accurate and reliable counting system. No doubt the manager would be pleased if the team played so well that the club had to install a microelectronic goal counting system as well. The main line, just north of Derby. Modern trains roar past every few minutes. In the past, steam trains huffed and puffed along this line. And round about here, the driver would check his progress by glancing at the clock on the local church. No more steam trains today, but the local church and its clock are still here. Clocks are very special kinds of counting devices. Old clocks are a mass of moving cogs and gear wheels. But the key part is the pendulum. It swings slowly backwards and forwards, each swing taking the same length of time. The pendulum produces precise, regular ticks of the same length. The rest of the mechanism counts the ticks and displays them. When the mechanism has counted 3,600 ticks, it strikes the hour. So, clocks produce and count regular ticks. Of course, today, mechanical clocks and watches are considered to be a bit old-fashioned. Now, the ticks are pulses, microelectronic pulses, but the principle is still the same. And that principle, timing, is used in lots of different ways.
6, 5, 4, we've gone for main engine start, we have main engine start.
Timing devices are literally at the heart of all space missions.
Has cleared the tower.
Space flights depend on computers, and every computer has a very accurate counting system. And perhaps surprisingly, timing devices are in use here. This is an open-cast coal mine. Millions of tons of rock have to be blasted and removed before the coal is exposed. But they can't just blast whenever and however they want. They have to blast efficiently. And there are rules about the limits for both noise and vibration from blasting. Which is why the blasts are designed. Not just one explosion, but 90 spread over several seconds. The explosions are arranged to go off in a fixed pattern controlled by a firing box. The firing box can control up to 10 lines of explosions. It's the timing device in the box that controls the gap between one line of explosions and the next. The timing is vital. Either too early or too late would mean the rock would not be correctly broken up. So, there are 90 holes to drill and 90 charges to be set. And 90 detonators to be wired up in the correct sequence. The control box acts as a timer by generating its own accurate pulses and counting them. And that's the result. 9 separate lines of explosions, each separated by an interval of time set by the counter. The rocks have been broken up as required. The expensive explosives have been used efficiently. There was only a minimum amount of noise and vibration. That's good for everybody. It's surprising where you find microelectronic timing counting devices. There are many advantages to shopping in a large supermarket. There's more variety, a freer choice, and often lower prices. These days, many people choose to do most of their shopping in supermarkets. Mind you, nothing's perfect. For instance, there's nothing worse than having to wait in a long queue at the checkout. In this supermarket, the queues do move quicker because the checkouts are fitted with laser scanning equipment. These days, most articles have a barcode, a series of lines in a particular pattern. Laser beams from the scanner read the barcode. All the cashier has to do is wave the articles over the scanner. The central computer translates the barcode into a description and price of the article. This information is relayed back to the checkout, which remembers it along with all the other items. As the cashiers don't have to search for the price ticket, they can work faster, which means the queues are shorter. The scanners are more accurate and reliable, and that in itself might be enough of a reason for using the system, but there are several other advantages. There's no need to use time and effort putting individual price tags on every one of the hundreds and thousands of items. And changing the price of a given line of articles is very easy, since the price is in the memory, and it only takes a few seconds to change it. But probably the main advantage from the store's point of view is that the system keeps a record of every item sold. It can provide an accurate system of stock control. Already the stock control is highly computerized. The stock level on the shelves is assessed every day and entered into a data logger. The data is then transferred to the main computer. It has a set of instructions in its memory which tell it how much stock to reorder. Messages are sent down the phone lines to the headquarters, where they're checked and sent on to the depot. The depot handles about 100,000 packages every day, and every one has to be accounted for, which is where the computer's memory comes in. As the goods are delivered from outside suppliers, they are entered into the memory. A label is produced which not only says what they are, but where they should be stored. In its memory, the computer has a record of all the shelf positions, and it knows which are empty and ready to receive the incoming goods. So at any time, the computer knows exactly what is in the warehouse and where it is. Orders from the shops pour in all the time. The computer arranges the lists according to the position of the stock in the warehouse. It's done in that way because the people who actually collect and make up the orders don't want to be going backwards and forwards all over the warehouse. That would be a waste of time and effort. Because the locations of all the items are stored in the memory, the collectors travel the shortest possible path, which means that the warehouse can be organized very efficiently. Fully automated warehouses are possible. Instructions from the computer's memory can be used directly to drive conveyors, which carry the stock from place to place. Now that works fine if all the stock is about the same size and the workload is the same, day in and day out. But here they're much busier at the end of the week than at the beginning, and the sizes of the packets varies enormously. So, for the time being, this warehouse will continue to use its present methods. But they'll still keep an eye on the new systems. There may be something to suit their needs in the next few years. In the retail business, they have to be as efficient as possible. They depend on having a large, accurate, fast and reliable microelectronic memory system. And when you have lots of computer memory, you can do some very interesting things with it. As you must have noticed if you've been watching any television recently.
I'm sitting here talking to you, and suddenly I'm in a little box, flying all over the screen like this. Whee! And with the push of another button, I'm upside down. And then I'm stretched out of shape, put back in a box, and sent tumbling into infinity and back again. And then over and over until... Oh, God. I don't get out of here. Oh, somebody help me. I'm going to puke. No.
Television pictures are a bit like pictures in newspapers. If you look very closely at a newspaper picture, you'll see that it's made up of dots. And so is a television picture, if you look very closely. And each dot can be described as a series of numbers. It takes 2 numbers to say where the dot is on the screen. It takes just 1 number to say what colour it is, and it takes just 1 number to say how bright it is. So the position, colour and brightness of each dot can be given as numbers. The numbers can be stored in a computer memory, and not just stored, but changed and then sent back to the screen. These pictures are being produced from numbers in memory. Of course, there are thousands and thousands of dots on a television screen, so a large computer memory is needed. And the picture is changed every 25th of a second, so the numbers have to be moved in and out of memory very quickly. Here in the Austin Rover drawing office, the old drawing boards have been replaced by computer terminals. The designers work faster, do new things and are more creative. And there's another advantage. The numbers stored in the design computer can eventually be used for the machines on the production line. So, the components being produced on the production line are a direct result of the numbers stored in the memory. These production lines run faster and more efficiently, and it's easier to make alterations, all of which means better cars at lower prices. It's amazing what you can do with numbers if you have a big, fast and reliable microelectronic memory system.
We've more problems for 10 to 12-year-olds to work on next in Mind Stretchers, starting in about 3 minutes.